So in last session we had two doubts. Okay. In last session we had two doubts. First was regarding centrifugal casting and second was riser. So in the centrifugal casting, if in the question, if it is mentioned that it is horizontal, then you have to take outer radius. Okay, outer dia. If it is mentioned vertical, then you have to take mean dia. Is my mic okay? Can anyone just please turn on your mic and tell me? Okay, I'm not able to hear you guys. Wait. Okay, now I think it is fine. The second doubt was with the riser. Okay, when to take the bottom surface and when to not. So if it is a top riser, then you no need to take the, if it is mentioned in the question that it is a top riser, then you don't have to take the, don't take the bottom surface of riser. Okay, or starting surface. If it is mentioned side riser, then you have to take. So casting, whatever we have done till now, that is you have to keep practicing. We will come back for casting again when we will solve questions. Now today I am starting metal forming. So this is the syllabus for metal forming, and then we will move on to building. So this is your full syllabus, and firstly we'll learn the concepts. So so your metal forming is divided into two parts. First is bulk metal forming and second is sheet metal forming. So firstly we will look bulk metal forming and then we will go for sheet metal forming. Both the topic is important only, so you have to focus on both. So these are some terminologies that like ingot, bloom, billet, slab that you have to know. So how do we get ingot, bloom, billet, slab? Can anyone tell? What is the process to get ingot? So when you cast a product, you directly get the, you will cast your products in the form of ingots, bloom, billet or slab. Or even if you are doing any forming process also, these are the standard products, semi-finished products through which you turn your molten metal. So ingot is the first solid form of steel. Then according to their dimensions, we have divided these things: ingot, bloom, billet and slab. So these terms like ingot or bloom or billet or slab, you may see in the questions that there is one billet and we rolled it, or one slab was there and we rolled it. Like that you will get these kind of terminologies. Now move on to the mill product, that is plate, sheet and strip. So what is the difference in all these? Slab, plate, sheet and strip, that is the difference of thickness. So you have to know all these things, like if the thickness is less than 5 mm and width is greater than 600 mm, then it is sheet. If width is less than 600 mm, then it is a strip. And if the thickness is greater than 5 mm, then it is a plate. So sheet metal forming is a different topic in your syllabus, that also we will see. Now so these are some metal forming processes that you have to. What is a forming actually? That forming is like you are changing the shape. Forming means you are changing the shape. So these are different processes only through which you are changing the sheet to make a desired product that you can use further. So these are the some animation that is on your screen. So you tell me what are these? Like, what is this one? By
Recording.
Rolling, right.
Rolling.
By the diagram only you can tell what are the forming process that is going on. What is this?
Forging.
Forging. What is this?
Extraction.
Right. What is this?
Wire drawing. Wire drawing.
Yeah, drawing or wire drawing also you can say. That is the difference between extrusion and drawing. Extrusion, push force will be there, and drawing, pull force will be there. Now, these are some other processes. Tell me, what are these processes? Give it a try. What is this one? Drawing. Yeah, deep drawing. What is this?
Blanking.
Okay. Yeah, this could be blanking, punching, or piercing, depending upon what is your workpiece and what is your scrap material, right? Then what is this? Okay, let me play this. It's not moving. Okay, what is this? This one?
Spinning process.
Spinning, right. What is this? This one? Okay, what is this? This you can do.
Shearing.
Okay, shearing or bending. And this is stretch forming. So one thing which is common in all these 5 processes. Can anyone guess what is common?
Sheet metal is used.
Yeah, correct. Very good. So these are the sheet metal forming process, and this was the bulk metal forming process. So firstly, we will go for bulk metal. So according to your workpiece, suppose your workpiece is the material that you blank, then it is blanking, and if the whatever you removed, that is your scrap, then it is piercing, right? So this is the difference that will be in your PPT. Later on you can recommend. Then 2 more sheet metal forming process like coining and ironing. Okay, that all we will see in the sheet metal. Now, what are the 4 important bulk forming techniques? That is rolling, forging, extrusion, and drawing. That all we have already seen by the animations. So rolling is like you are plastically deforming your metal by passing it between rolls. Okay. Suppose if rolls are being used and you are doing forging also, then you will call roll forging. Then the forging. Forging is what? Workpiece is compressed between 2 opposite die. So that whatever the shape the die has, that will be imparted on your work. Then the extrusion is the work metal is forced to flow through a die opening. And in the drawing, the diameter of wire, it is the difference between extrusion and drawing. Extrusion will be a push force and drawing will be a pull force. There are many more differences in extrusion and drawing that we will see. Okay. Now this is also in your syllabus that you should know all these terms: plastic deformation and yield criteria. So all we know that after reaching the yield strength, your plastic deformation will begin, right? So yield point is the point on this stress strain curve where the deformation of a strain material transits from purely elastic to plastic zone. So before reaching the yield strength, elastic deformation will be there. After reaching the yield strength, your plastic deformation will start, or your strain hardening will also start. So I assume that little you all know about strain hardening, yield strength. So how we get this yield strength? That is the old method. Firstly, we will just draw a parallel line, the proportional limit line, and then from starting to 0.2% of the strain that we will mark, and that will also call your yield strength. Okay, this is the method to get the yield strength from your stress strain curve. So this all you know. So for the yield also you know, yield criteria is like after yielding strength, your plastic deformation will start. One more thing is spring back.
What is the strain hardening? What is the strain hardening?
Strain hardening. Strain hardening is like your metal is getting harder and stronger due to plastic deformation. Why this happens? So what happens actually on like metallurgical, what happens, dislocation will be generated. Okay, after your plastic deformation will start, your dislocation will generated. What is dislocation? Okay, dislocation is a kind of defect, and your plastic deformation happens through the dislocation only. Okay, so more number of dislocation will generate, and then what happened, these dislocation will start interacting with each other, and they'll start pinning. Okay, these things you will learn in material science. They will start pinning at some point. So because of that, further deformation will be arrested. Okay, suppose you have plastically deformed your material here, so there will be some plastic strain will always present in that. Due to that, more number of dislocation will present, that will start interacting with each other. So next time when you will start to deform this material, you have to put more strength to in order to deform that material. So this effect is called strain hardening. The more you strain something, the more hardened or stronger the material will get. That is what is called strain hardening. What is necking? After ultimate tensile strength, necking will happen. So can anyone tell what is the difference between plastic deformation and necking?
Necking is that cup and cone arrangement.
Yeah. After like fracture, when the fracture happen in a ductile material, cup and cone something like form. Okay, when the this whole process, cup and cone will form. Here also plastic deformation is happening, right? So why is this forming? And we are calling necking. After ultimate tensile strength, this will not uniform. At some location where your material is weaker, at some material significant amount of area will be reduced. The way she said, that is correct. Then that what we call as necking. After ultimate tensile strength, at some position the area will start decreasing significantly or abruptly. Okay, it will here till here there will be gradual plastic deformation, but after reaching ultimate tensile strength, abruptly somewhere your area will decrease. That phenomena is called as necking. Okay. Okay. Now next move on to spring back. Spring back is what? Elastic recovery of a material after unloading of the tools. So suppose you load it in elastic region, whatever the elastic deformation will be there, that will be recovered after that, right? So that is called elastic recovery. So while forming, when you are forming, you have to take spring back as into consideration. Suppose you want your final product to be like this, but due to spring back effect, it is moving back. Some less deformation is coming. So that is why back effect you have to take in consideration. So okay, these things that we just discussed. That
Ma'am, hello. Ma'am, elastic recovery we taken about initial length or which deform and again deform.
elastic recovery, what? I'm not getting you. No?
Ma'am, just like in problem, we found the elastic recovery. What is elastic recovery?
See, they will not ask you what. They will even ask you till here. What is the relationship between stress and strain? Can you tell?
It is proportional to.
Okay, so this is your elastic limit, then the proportional limit. After that, plastic deformation will start, right? So in the plastic deformation, so you can tell me what will be the elastic deformation in this zone, in your elastic limit. Tell me what will be the strain.
Sigma by elasticity, young modulus.
Yeah. So till here, if they are asking elastic recovery, if they strength, that you have to take true strain, then you have to take true strain. If they didn't mention anything, you take engineering strain, right? So if you will
Yes.
take engineering strain, you have to take uh, anyway, you have to always take initial length only. The both is same only. They will not ask you to calculate elastic recovery, but it's just the strain only, elastic strain. Okay.
Okay.
Now the spring back effect. So this is all what we discussed till now. Deformation beyond elastic limit is what? Plastic deformation. And how it happens? It is happening due to slip, and your grains are fragmented, and movement of atoms and lattice. That's how your plastic deformation is happening. Bulk deformation processes. Large amount of plastic deformation will be in bulk deformation processes, and your cross section will be changed without changing the volume. And the ratio of cross section area divided by volume is small. For most operations, hot or warm working conditions are preferred, although some operations are carried out at room temperature. Then uh, strain hardening and flow stress. So strain hardening we already discussed. So what is the flow stress? So till your elastic limit only, this till your elastic. Okay, can anyone tell me? Uh, okay, I've already told. So till your elastic limit only, this formula. This is the relationship between stress and strain. Okay. After your elastic zone, when we'll move to plastic zone, this is your relationship between stress and strain. Okay, because strain hardening will start. So this is your relationship in the plastic zone. Suppose whatever the deformation, whatever the informing, why we are very much interested in the plastic zone, because what we are doing, we want to do plastic deformation. Okay, that is how we will change the shape. We are no more interested in the elastic limit, because it will recover after we'll remove the load. So we are more interested in the plastic zone. So this is the formula for the plastic region. Sigma is equals to K epsilon to the power N. Then again we have to, this is what you call flow stress, and then this also you need to know average flow stress. So average flow stress, you are not considering instantaneous flow stress, but you are considering an average value over the stress strain curve. So the formula for it is actually sigma average will be, this is average of this diagram, so it will be 1 upon epsilon. You integrate this graph only, K epsilon to the power N d epsilon. This is your formula. This is very important. Even if you don't remember this, you have to remember this one. This is very important. Okay. This is just what is your average flow stress. It is the average. So what we are doing, we are taking an average only of your instantaneous flow stress. This is what your instantaneous flow stress, and when we are taking an average. So this formula you remember. Later on today only we will solve your question, then you'll get to know how and when we are going to use this formula. So in the plastic zone, you have to remember firstly the flow stress, and one more thing. At U, your epsilon is equals to N. These three things.
Ma'am, by stress flow, do you mean the gradient of the stress?
Sorry?
What do you mean by the stress flow? I mean, is it the gradient of the stress?
See, what is actually flow stress? Like it is a stress that is needed to deform a material at constant strain rate. Okay, in the plastic range. So you have to provide a constant strain rate, because now it is plastic deformation.
Okay.
So easily what you can understand that after your elastic limit, whatever the stress you call, it is a flow stress.
Okay.
Constant of strain. Okay. Because the material is flowing. So stress which is required to flow your material. That is your flow stress. It is a okay. You understood?
Yes, ma'am.
Okay.
Flow in the sense cascade deformation.
Sorry. Yes. Yes. Correct. Okay. Then sheet metal processes.
Madam,
Yes.
what was the outside integral?
Sorry.
What was the term outside of that VIM integral? 1 upon
Epsilon. This is 1 upon
and
epsilon
we are into
integration of k e to the power n d sigma.
DC is it
This
sigma.
is sorry. What is epsilon?
Strain.
Strain only.
So that 1 upon epsilon should be also inside. No?
I feel you are taking average, right? This is what? How do you take an average when one graph is given? This is what the value, because you don't know at one single point, right? This is the way we take average, right? So after that, how many numbers are there? How you do? N1 plus N2 plus N3 divide by
Total numbers.
total numbers. So that is how you are doing.
Okay, means inside integral. Inside integral, the epsilon is instantaneous. We can
This
say.
is what we are doing. We are taking average only. It will be instantaneous. What is this? This is flow stress.
Okay.
Okay.
I also wondered. Actually, the shape of the graph actually is it increasing till the fracture point, or we have drawn it till the UTS here?
UTS only.
Okay.
Okay. See, after UTS, it will decrease, then fracture will happen, right? At least little amount of decrement will be there. Then you can say. Okay. Next, sheet metal forming that we will see maybe in the next class, or if we'll be able to cover. So in the sheet metal forming, the cross section of workpiece will not change, only shape will change, and the ratio of cross section area to volume will be very high. Okay, so we will see many sheet metal forming operation. Then the recrystallization temperature, because there will be two types of forming, mostly hot working, cold working. So hot working will be above recrystallization temperature and cold working will be below. So the minimum temperature at which the after completed recrystallization of a cold work material occurs within a specified period of approximately 1 hour. Suppose you have reached to recrystallization temperature, you have cooled your material to recrystallization temperature. So after that, after 1 hour at that temperature, it will be recrystallized completely. That is your recrystallization temperature. If you are working above recrystallization temperature, that is hot working. If you are working below recrystallization temperature, that is cold working. Then these things I'm leaving on you. You should know. So the main points are like, for pure metal, your recrystallization temperature will be 0.3 into melting temperature, and for an alloy it will be 0.5 into melting temperature. Then the grain growth, these things I assume you know. Let's start with the cold working. So cold working is what? Working below the recrystallization temperature. So what are the advantages of cold working? It will give you better surface finish, better accuracy, strain hardening. See, strain hardening will be there in cold working. So it will increase the strength and hardness. Strain hardening, and then no heating of work required. What are the disadvantages for cold work? Cold working. So you are doing at the room temperature, right? So more higher force will be required because your material is hard, and ductility and strain hardening limit the amount of forming that can be done. In some operation, metal must be annealed to alloy for the deformation. Suppose you're doing it at room temperature and your metal is brittle. Okay, So it is not easy to deform it. It will break or something. So these are the disadvantage of cold working. So what kind of grain you will form? Suppose you are doing rolling, basically, then in rolling your grain will be elongated in the rolling direction. That is what shown in this diagram because it is cold working. In the hot working, that we will see also. So what is hot working? Hot working is working above the recrystallization temperature. So what are the advantages? There will be no porosity. The grain structure of the metal is refined. Okay, the impurities are squeezed into fibers and distributed throughout the metal. And mechanical properties like toughness, ductility, and all percentage reduction, elongation that will be improved. What are the disadvantages? It is expensive. It will give you poor surface finish due to rapid oxidation, scale formation, and close tolerance cannot be maintained due to poor surface finish. Then this is the microstructural changes in hot working. Deformed grains will be formed. So after the hot working, your recrystallization will start. So recrystallization will start, it will easily cool, and your final grain structure will be achieved in hot working. Then the rolling. Rolling is very important for your gate perspective, and they are improving their questions every year. Okay, at my time the questions were easier. So rolling, you should know, it is not they are asking you very high-fi things, but let's understand what are the concepts where forces and stress are required. So rolling is simple process of plastic deforming in between rolls. Okay, this is the most common forming process. So there will be friction between the rolls, and it will due to that high compressive stress will be there. It is hot working. Okay, in the question if they have not mentioned cold rolling, you have to take at hot working, and your metal will go under biaxial compression. Okay, then hot rolling, same as hot working, your it will be done above the recrystallization temperature. Fine grain structure will achieve. Again, surface quality and final dimension will not as good as cold one. Then whatever the ingots and bloom that we have seen, ingots, blooms, and billets, that are breakdown of those things are done by hot rolling. Then further we do hot rolling, and then we make plate, sheet, rod, bar, and pipes. So hot rolling is will stop or terminated when the temperature falls to about 500 from 50 to 100 degree above the recrystallization temperature. Then change in the grains that we have seen. So whatever these kind of alloys are called as wrought alloy or wrought metal. Like two different kind of metal form is there. Firstly, directly if you will buy cast alloy that you will directly get from casting, or wrought alloy. Wrought alloy means some kind of plastic deformation or cold working or something is happened on your alloy, that is called wrought. Okay, then one thing you have to remember, that hot rolling is an effective way to reduce the grain size. Then
Madam,
yes,
previous to previous slide.
this one.
Okay. What was the last point? 50 to 100 degrees Celsius above recrystallized temperature.
See, it should be below, I guess. It is saying that below 50 to 100 degrees Celsius of recrystallization, your rolling will be terminated. Okay.
For hot rolling, I think it is correct. It is above recrystallization temperature.
Hot rolling will be above the recrystallization temperature. I'm telling it should be. Okay, this is the geometry. Okay, there are few things that you should know, that your initial height is called h naught, your initial velocity will be v naught, final velocity of sheet will be VF, then final thickness will be HF, then this is what we call as projected length, and this is what we call as contact length. Then the angle between the angle that what your contact length is projecting on the center of your roll is called bite angle or alpha. So these are the terminologies that you know. Then let's see the formulas. Okay, so what is draft? That is delta H, like how much draft you want to do the reduction in the height. So what is the formula for that? D into 1 minus cos alpha. So what is your contact length? L is equals to R alpha. Mostly it is R is equals to R is what? R is your radius. Then maximum draft which is possible will be mu square R. It depends upon the friction coefficient and your radius of the roll. So see, your sheet should go. Your sheet should move in front of from front to back with the roller. So what plays role here? Your friction plays a significant role here. So we have one condition for that your friction from your mu should be greater than the tan alpha. Then only your sheet will move forward. So for rolling has to be done, they will ask you maybe the question that what is the minimum friction that is required. Then one more condition that we assume in the rolling is like continuity equation of the rolling. Initial volume of your work will be the equal volume of the sheet. Then how we will check the number of passes required? That is delta H required divided by delta H max. This is what you want, and this is the maximum possible that you can do. So how many passes will you take to deform your material on a required height? That you have to use this formula. Then this is the concept of backward slip and forward slip. These formula all you should remember that I have mentioned.
In case of number of passes required, like we are just considering H, delta H required is a total change in height.
Yes.
And delta H max is per pass, is it?
Delta max, see, what is delta H max? What is minimum possible you can do? Like how much reduction is possible with by this ruler? Like suppose I have a 100 billet, or you can say slab. I have a 100 slab, and I want to do reduction, and I want final thickness as 10 Okay. So what will be the maximum? Your maximum draft possible. What will be the draft here? We want our draft to be 100 minus 10. That is what? 90 So 90 draft we want, right? So there is one condition. What will be your maximum draft possible? Maximum how much you can reduce. So that depends upon the friction coefficient and the radius of your roll, right? Suppose your maximum is coming around delta H max possible, that is suppose it is coming around 9. So then how many passes? Firstly you will go for 9 reduction, then again you will go, then again you will go. So how many passes will be required here?
10 passes.
10 passes. So this is what it is telling. Number of passes needed, how you calculate. This formula you don't have to like remember. The concept you should know. Okay. Then see, okay, what actually happens, how you decide how much what will be the final thickness of your sheet or a slab. So what we do, we give some roll gap. Okay, suppose there is a roll gap of 10 okay, and your final initial value is around 50 So definitely when this sheet will be pressed around the roller, this will push it. This will push your rolls backwards, right? In the opposite direction. That your sheet will push your rolls in the opposite directions, right? So this force that is applied by the workpiece on your rolls is called as roll force or roll separating force. Okay, so that is a formula for your roll separating force, which is sigma naught LP B. LP is what? Your projected length. That we have seen, your contact length is R alpha. It is actually R sin alpha, and then we assume that sin alpha is very small, then we write it as R alpha. But if in the question, when you are solving the question of, like, suppose they are asking you to calculate roll separating force or torque or power or something like that, then you have to take it as R sin alpha. If alpha is not given, then the projected length or contact length will be under root R delta H. Okay. So what is your roll separating force? This formula you learn. Firstly, whatever the stress will be induced, that is sigma naught, which will be given, multiplied by the area. B will be what? B is the that width that will be given, and L is what? See, why we are taking? You have to take this much area only. This much area. This whole area. Your sheet will be like that in 3D, right? It will be like that. So you have to take this much area, because this much area is only touching your roller. So this much area will be this much area will be try to separate your rolls. So this area you have to take while calculating the roll separating force. Okay. So these are the formulas, and these are very important formulas for torque and total power. They will ask you easy question, but you should know these formulas. Okay. Now we
Arm movements.
yes.
Arm movements.
See, when you are, how will you measure a torque? For measuring torque, you will put one arm, right? Then you will how I don't know if you know how we measure a torque. You will when you will put one arm, then with that arm, how much displacement or that is happening, that you will measure, and with that you will get the torque which is happening in your roller. So this arm length is actually that arm only. So the formula you should remember, and how much arm length we take for hot rolling and cold rolling, that also you need to know. Okay. So with the torque only, you will calculate how much power is required to rotate your roll. See, firstly, you need to know that your roller should be strong. It has that much power that whatever the force that your sheet is giving your roller, that it should sustain, and with that also it should roll. So we have to know that how much total power is required to give the rotation motion of your rollers. So that's how we calculate torque. I'm also forgetting, but I'll show you how we calculate torque, how we put arms on that. This is that arm length only, that I'm sure. I'll show
In
you
case delta H is given, then we will use the formula root delta.
Mostly it will not given. You should know the formula. 0.5 LP for hot rolling, 0.45 LP for cold rolling. Mostly it will not given. These days I have seen in recent year they are not asking these three things. But before that, like before 18, they used to ask power also and torque also. So these days what they are asking, that we will solve now. Let's see this one big question. Then we will move on to the other forming process. So today we will solve 2 marks question, big questions, so that in later class when we will solve multiple choice simple question, that would be easier. So read this question and try to solve this question. If you need any formula, ask me. I will go back to the slide. so that you can write. Firstly, read the question, try to understand whatever it is telling. I told you where the stress will be there, everything I told you. Now read this question and try to get what they are asking. And let me know if you want to see any formula.
Not those formulas.
This one?
Yes, ma'am. Have taken the screenshot.
Okay.
Thanks.
Ma'am, can you explain that what is draft in that previous slide? I mean, is it the full length of after rolling?
Which one?
Draft. Yes,
See the average.
okay, ma'am.
Of width 100 mm. We'll write first thickness, your H naught is given as 4 mm. Then diameter is given for your roller, that is 200 mm. Then what else is given? Mu is given. Mu is 0.1. Flow stress of the material is given. Okay. Flow stress is given as 207 plus 414 epsilon. Okay, one more thing. What is this? Is what? This is your flow stress only, average flow stress. Then, assuming rolling to be a plane strain deformation process, the roll separation force for maximum permissible draft that it is asking. Firstly, it is asking force. Use this formula where sigma bar is average flow stress, L is roll workpiece contact length, and H bar is the average sheet thickness. Okay, fine. So see, they are asking you force and they have given one formula to be used. Okay, you don't have to go back and look. And then that formula also they have mentioned what is what. Sigma bar is average flow stress. So that is not given, but flow stress is given. And we know the formula for average flow stress. What was that? So that's how you calculate first the average flow stress. Then mu is given, L is not given. L is what? Contact length, that was R delta H. Right?
Ma'am, L 10 mm.
What is synonym? Okay, yeah, correct.
Contact length of the workpiece. R into delta H 100 into.
Correct. Yes, correct. Okay, so for delta H, what you have to know? Delta H what? Delta H how you will calculate? That will be mu square R. Okay, from here you will get the delta H and from there you will get the L. What else is there? Width is given only 100 mm. H bar. H bar is what? Average sheet thickness. So average will be what? Initial plus final divided by 2. So initial you already know. If you will calculate delta H, you will get to know what will be the final also. So this is also you will get to know. So now calculate. So whatever you will get, then you have to fill in this formula and you will get the answer. Calculate.
For calculating the contact angle, so contact length, in case they've given the alpha, then we will use that formula, right? Otherwise, we are using this root r delta h.
One thing they will give, either they will give you alpha or they will give you mu and r both, so that you can use this formula. One thing they will give, either they will give you mu or they will give you alpha. So L is coming as 10.
Ma'am, is average flow stress and flow stress calculated from formula is same?
Sorry, just now we discussed average flow stress. Huh? What is average flow stress? It will be 1 upon epsilon integration of your flow stress d epsilon. This was the formula. From here you will calculate your flow stress. Is what? Integrate this one. Whatever, if it is not given, then they will give you in this form. If it is, they have given this equation, use this equation as your flow stress. So when you will integrate, it will be 207 epsilon plus 4.
Madam, it's coming 350.300777.
Yeah, correct. Okay, this is this. Okay, then your average flow stress will be, okay, let's write this formula, 207 1 plus epsilon. Right, we'll do this. This will also be 207. Okay, now what will be your epsilon? Your epsilon will be true strain. Okay, so it will be ln h. Okay, this is ho divided by hf. Right. What is your f here? Its initial
HF is 3. 0.2876.
Then you will put this value here and your average stress will be 266.53 megapascal. Now you have all the values. We will find. Yes. HF what?
It's a value is 3. How, ma'am?
Okay. Firstly, you have to get the delta H. That will be mu square R. So it will be 0.1 square into 100. See, your diameter is 200, your R will be 100. So it will be delta H 4.
1 minute.
Okay. H naught minus HF is 4. No, this is what? 1. This is 1. So it will be 4 minus 1. Your H final is 3.
Okay.
Your average will be 3.5. Now you fill all the values in this formula. Okay, you have calculated L, W is given, mu is given, H bar you have calculated, and average flow stress also you have calculated. So when you solve, your force will be coming as 351 kilonewtons. Any doubts in this question?
I'm finding the true strain.
True strain. Okay. What is your confusion?
What are the different ways we can calculate the true strain? Here we have used LNHO by HF, right?
Formula for true strain is what? It is what? ln 1 plus engineering strain, right?
1 plus engineering.
Then we simplify it. If it is length, if it is increasing, then it will be in final by initial, right? When it is decreasing, like here it is decreasing, or when it is in the case of area is decreasing, right? Your length will increase, your area is decreasing, so it will be initial by final. So here your thickness is also decreasing, that's why I take initial by final. Otherwise it is what? Final by initial, right? So this is the way you can use any of these formulas.
So whenever the dimension is increasing, we use final by initial dimension.
Otherwise what will happen? Nothing will happen, you'll get a minus here.
Yes.
Okay. Then also you just take the magnitude, don't take the direction, don't take the sign. Okay. But if they are asking like in some question they will write it as magnitude only, then your answer will be correct, otherwise your answer will be wrong. So if it is decreasing, then keep this in your mind. Here area is decreasing, that is why initial is a naught by a, and here length is increasing, that is why it is L by L naught. Okay. Okay, now let's move on to forging. So forging, we know forging is how what we do, the few things that you should know and remember in the forging, that your forging will provide you the best mechanical properties because it will improve your crystal structure. Okay. And it will, because significantly it will reduce the grain size. If your grain size is reduced, your strength and toughness will be increased. So mostly forging gives you the best mechanical properties. But what are the disadvantages? That it is very costly and it has poor dimensional accuracy and surface finish, and it is very limited forging. Then what are the types of forging? There are 3 types: open die, closed die, and impression die forging. Open die, that animation that I have shown you, that is open die forging. Closed die, your die will have some kind of shape, and it will be your workpiece will be fully closed between your die. It will be forged in a closed die. Then the impression die casting. In impression die casting, you want some kind of specific shape, and flash and gutter. There will be one flash, so gutter will also be there. So what is flash and what is gutter? So sometimes what we do, we provide some extra metal in this kind of impression or cold die forging. We provide some extra metal so that there will not be any empty spaces. Right. Okay, like some excess metal we will provide so that there will not be any empty spaces and your cavity will be full. So it will work as a cushion for, during the forging. Since we are providing some extra excess metal, then we have to provide some space for that metal in the die itself. So that extra metal is called as flash, and that extra space in your die is called as gutter. Okay, these two terms you should remember. Sometimes they ask question about on what is flash, what is gutter. Then this is just now that we all discussed formula for true stress, true strain, and your flow stress. Then these are different kind of what we say forging operations that you read and you should know. How we start forging. These are the sequence in a closed die forging. what is it called, that you should know. Then one more, during my time I didn't read this thing, but in recent years they are asking question from this also. Suppose you want to make a screw head, or you want to make a screw, you want to increase diameter in a specific part of your rod. So then what you will do, you will do upset forcing, upsetting. That is upsetting. What is it? It is the increasing the dia by compressing the length. Okay, what we are doing, we are increasing the diameter by compressing the length. So this is also called hot heading process. So how we do that? This is a principle that you all know. One thing you all know, that we make crankshafts by using of forging. Why? Because firstly, your forging will provide the best mechanical properties, but you may feel how we make crankshaft. So that's how, with the use of upsetting or upset forging, we do crankshafts or bolt or nuts like that. Then how we do that? This is the diagram. This is your workpiece. Okay, this is your workpiece. This is your fixed die, stationary die, and this is your moving die, and this is your cavity impression that you made on your die. This is your punch. Okay, by that you will push it. Then you, what you do, you moved your moving die, and now you gripped your material. Your workpiece is gripped. Okay, now your punch will move, and whatever the cavity was there, that will be filled, and your diameter will be increased. This is called as upsetting. Okay, that is how they make screw bolts. Okay, everyone, I hope everyone understands. So in the gate 18 or 19, they asked this question, one question, that suppose you haven't provide proper what we say distance here, or proper die size. If you haven't used, this will buckle. This part which doesn't have any support here, these are fixed, they are having support of die. This part which is not having any support, there are chances that it will buckle or swap. Okay, so for that, what we do die designing. Okay, so there are this kind of thing, crank, screws, bolts, engine walls, that we made by upsetting or upset forging. Then these are 3 rules to do the die design in your upsetting. First is your L should be greater than 3D. D is what? The diameter of your workpiece, and whatever this is what? Unsupported workpiece. Okay, this is under die, this is that we are going to be deformed. That should be always less than 3D. If it is over 3D, it will buckle. Okay, if it is less than 3D or 3D, it will upset. Then your rule number 2. Suppose you're not able to fulfill the first criteria. Okay, if you are not able to fulfill the first criteria, then you have to fix your die cavity width as this, and you have to provide some free length to your unsupported workpiece, that should be less than 0.5D. This is the another condition. If rule 1 is not satisfied, this condition, rule 2 you should follow. Okay, then this is the third rule. Suppose your first rule is also not being satisfied, and your second rule is also not satisfied, then you have to use one heading tool and one more kind of attachment, and these conditions is formed. Mostly they will never ask question from the rule 3, but rule 1 and rule 2 you should know. Okay, then let's solve a question on this. Read the question, and if you need me to go on the previous slides, tell me. Okay, read this question, get to know in which rule it is falling, and then solve this question.
Rule 2?
Sorry?
Is it falls under Rule 2?
I couldn't understand what you said. Can you please repeat?
This is this case of Rule 2?
Yeah, correct. Get it right. So, what they are asking? They are just asking you the cavity width, right? Diameter. So this will be the width, and this is your diameter also. So what is the question? A bolt head has to be made at the end of rod diameter is given 12 mm. There is one rod and you have to make a bolt. So you'll use, what will you use? You'll use upsetting. The length of unsupported portion of the rod is 40 mm. So it should be always less than what? 3D. So 3D is what? 36. So it is greater than 3D. So it is what? It is the case of, since there is they are asking you to design the die, so this is the case of rule 2. So what rule 2 says that your die should have diameter 1.5 D. What is the answer? So D will be
18. 18.
18. So this is your answer. Okay, any doubts in this?
No, ma'am.
Okay. Now come to the final bulk forming processes. Extrusion. Yes.
There are no any other formula or equations involved in forging, right? Only these three
So
conditions.
most of the time they will ask you like to calculate the strain. That all you have to use that flow stress formula. They will give you the flow stress. They will give you plastic deformation condition. Then they will ask you the strain, or they will ask you to calculate the flow stress. That kind of question we will solve. There are formulas, but most other question will be based on this. This one question that I have seen was on this concept. That's why I told you. If any other question is there, because see, any forming concept is very vast. Number of designing things will be there. Number of formulas are there, but in my time, this concept, we haven't read this concept. But since they asked in the gate that you should know, so whatever the concept, if the formulas which are required, that I will tell you in the class. So most of the other forging questions are based on flow stress only. If you know the concept of flow stress, you know how to calculate flow stress, and you know the true strain and all, then you will be able to solve other forging questions that we will see in the class.
Okay.
Then move on to extrusion and dry. So what is happening in extrusion? Your metal will be compressed and forced to flow through a suitable shaped die to form a product with reduced but constant cross section. In this, your material will go into triaxial compression. In rolling coat, it was biaxial compression, right? Then mostly we do hot extrusion, and these are the few metals that are mostly extruded. Then there are some metals like steels, stainless steel, nickel-based alloys. They are very difficult to extrude. So in that case, we use lubricants, phosphorus-based and molten glass lubricants. Then what is extrusion ratio that you should know? This term, there are few terms that you should know in extrusion. What is extrusion ratio? Ratio of the cross-sectional area of the billet to the cross-sectional area of the product. Okay. Then there are different types of extrusion. The category is divided into two parts: hot extrusion and cold extrusion. In hot, it is direct, indirect. In cold, it is forward, backward. In forward, they use hydrostatic. In backward, there is cold extrusion forging or impact extrusion. So most of the questions, like a numerical based question, will be from hot extrusion, or if it is mentioned, then the cold extrusion. Other you have to know, like what is backward cold extrusion, what is forward, what is hydrostatic extrusion. That all we will see in the class by pictures. Then what is hot extrusion? There is one temperature range for that. it will be above the room temperature. Then what is direct, what is indirect? So indirect extrusion, what we are doing, we are giving a push force to the billet. So in that you can say your billet will be moving, right? You are moving your billet through a dry. Your billet will be flow from this cavity. What is happening in the indirect extrusion? Again, you are giving pushing force only, but here your billet is stationary. It is not moving. So there will be no relative motion between the billet and your die. So less friction will be there. So less power will be required. Okay, that is the advantage of indirect over direct. Then then this is cold extrusion. So the metals which are having low strength, lead, tin, zinc, and aluminium, they are mostly we used cold extrusion for that. One important thing that you should know, that these kind of collapsible tubes which are being used for toothpaste, creams, or small cans which are of shield of electronic components, that are made by cold extrusion. Okay. So these are the formula for extrusion load and extrusion stress that you should know. And now we will solve this question. Now we will solve.
Ma'am, what is A0 and AG?
A0 and AG is not, it is AF. This is A initial,
Oh,
this is
okay.
A final. Cross section, okay?
Oh, okay, cross sectional area. Okay.
Yes. In extrusion, you have to take cross sectional area, even if you are calculating extrusion ratio or you are calculating load or stress.
Got it.
Okay, this is a question from 2022. Read this question and try to solve this question. Read the question and try to understand what is it asking. They like that they have also mentioned the formula. They are asking you force required, maximum force required, and pressure they have already given, formula for the pressure. So all you have to do, you have to find the pressure and then you have to multiply it by the original cross section area. Try to solve.
Ma'am, here for calculating the force, which one should I take? Like initial area or the that final area?
Initial, they are asking you calculate it at the start of the extrusion, right? So you have to take
Okay,
initial
okay.
area.
No, isn't it direct substitution of values?
Sorry?
Isn't it direct substitution in the formula?
Yes, almost. The only thing that you have to calculate is what? Okay.
Extrusion ratio.
Yes.
Extrusion ratio.
Yes, yes. So what is given in this question, that there was 100 mm and 100 mm length and 100 mm diameter billet. So this was a billet whose diameter was 100, whose length was also 100 mm. So you have to make an L shape from this billet by extrusion. Then the cross-sectional dimension of cross-section is given. Okay, this is how you have to extrude it. Then the total extrusion pressure is also given by this formula. Then they are asking what will be the force. So one thing that we know the pressure. Sorry.
I'm getting the answer is in large number, like 24,29,204.598.
Calculate in kilonewton.
Okay.
Okay. Then pressure is also
2429.204598.
Yes, correct. So pressure is what? Pressure is your force will be what? Pressure into initial area, because what they are asking, maximum force required at the start of extrusion. So it will be cross-sectional at extrusion, A initial, that you have to find. Now let's see in P whatever is given. So first term is Ks. So Ks is given, die shape factor 1.05. Then what is given? Sigma m is what? Mean flow strength. That is also given. Mean flow strength of a billet is 50 MPa. Then ln R. R is what? Extrusion ratio. Okay, we will calculate. What is extrusion ratio? Original cross-section area divided by final cross-section area. So original cross-section area will be pi by 4 d square, will be pi by 4 100 square upon final cross-section area. Okay, there are two ways. Either you minus this much area, calculate for the minus, or you just add this area. So it will minus.
मैम इसमें हम हमेशा क्रॉस सेक्शन एरिया ही लेंगे.
Yes. Definition, that is definition of extrusion ratio.
Okay.
Into 50, right? So what is R? Will be pi by 4 divided by, what is your R coming?
7.854.
The voice just break.
7.854.
So now you know R also. D naught is already given. D naught was what? Initial diameter, which is already given here. And next is what? L. L is what? L is the portion of the billet length remaining to be extruded in mm. Okay, so tell me, at the start of the extrusion, what will be the length which is remain to be extruded? Beginning of extrusion?
Total length,
correct. So your
Complete length.
100 mm. Here you will take 100. Now you have everything. You have L, you have R, you have sigma m, you have Ks. Now fill all these value into your P and tell me what is P here. What you got for P?
309.296.
2 into 100 by 100. So 309.296 MPa.
Ma'am,
Yes.
one question. The answer is already we are multiplying with already MPa. Then why should we divide it with 1000 to get like kilonewton? The already in.
No. See. I will take that. See, now what is the pressure? The pressure is in megapascal, right?
Yes, ma'am.
And whatever the values you are putting, it is in mm, right? So whatever the answer force you will get it will be Newton, right?
Already 1 MPa, 1 kilonewton, MPa equal to 1000 kilonewton.
MP is what? MP you can write is at
Newton per meter, mm square.
Mm square.
So Everything is in MP only. So this answer that you will get, it will be in Newton. Now you only told that this
Okay, okay,
is
okay.
very big. So you will
Okay,
convert
okay, okay.
into kilonewton. So your F will be 2429.278 kilonewtons. Okay, any doubt in this question?
No, no, ma'am.
No, so like by just knowing the extrusion ratio and the code working initial extrusion formula, like we can tackle the questions, right? So
It was given here. When it is not given, you know the formulas, right? Mostly now they are not asking you on these formula. They will give you some relation.
okay.
Okay.
No, but this will be overall like regarding extrusion. This extrusion ratio alone was enough in this question, like the was.
Yeah, in this question. Because I took this question because it looks very big. It is a recent 2022 question, but how simple this question is, right? If you know the extrusion ratio only, and if you get to know what you actually need to find. Now other questions will be easier only. You should also remember these two formulas. Suppose they have not mentioned the relationship. Here they have mentioned the pressure relationship, right? If it is not given, you take this as your. They have got this by the formula, this general formula only. Suppose they have given some stress relationship in your question. This is the your extrusion stress is related by this some equation they have given. They will get that equation by using this original condition only. So if some formula or some equation is already mentioned, then it is easier only use that equation. If it is not mentioned, then you should remember these formulas. Okay. Okay, now move on to wire drawing. So as I mentioned, these things, whatever mentioned in PPT, you read before we'll go to next class. We will solve all the questions from this topic in next class. So before that, I want you all to read the PPT. I will upload one more notes in which you will see the defects also. What are the defects in forging or rolling or in drawing extrusion? Those also you should know. Then there are some miscellaneous type of wire drawing processes or forming processes like seamless tube drawing. So many that also we will discuss. I will show you by pictures what is what and what is the application. So these kind of things you should know before solving or jumping to the all gate questions. So this will be the last topic, wire drawing. So wire drawing, what we do. Wire drawing is means if you draw means you're drawing something, you're pulling. Drawing, if it is wire is not there, that means some pull force will be there. By pulling, you're changing the shape of your material. Suppose it was a billet and your some die is there and some shape is mentioned in your die, and if you are not pushing it, you are applying pulling force, then it is what? It is drawing. Okay, in wire drawing, from a billet or something, you will draw a wire only. That is how it is called wire drawing. Then these are the formula that you should remember for the wire drawing. Okay, mostly they will mention only because this formula is very tough to remember, but you should know drawing stress. This one formula that you should know, and then this formula when back stress is there and when back stress is not there. Then you all please take a screenshot of this question and try to solve this question on your own. We will discuss the answer in next class. And let me read this question. Initial diameter is given, final diameter is given, alpha is given, then mu is also given, and wire mu is also given, then average initial and final stress is also given, and then they have given you one equation for the drawing stress. What they are asking, drawing stress. So I think you will be able to solve this question, right?
Yes, ma'am.
Yes, ma'am.
Then take a screenshot of this question. In next session, we will see the sheet metal forming also, and we will solve the questions.